There are a number of biocides used in oil and gas operations today. In order to design an effective microbial control program, it is important to understand what their strengths and weaknesses are. Commonly used biocides distinguish themselves from one another in terms of their reactivity, selectivity, and compatibility, and how they perform under different environmental conditions, such as high pH, salinity, and/or temperature. It's important to consider the needs of the different phases of hydraulic fracturing. When preparing the water, a quick-kill biocide is required to knock down the bioload in the source water. Decontamination of the well occurs through on-the-fly treatment that provides microbial control for a few weeks. This is where biocides first come into contact with all the fluid additives. In order to protect the reservoir after decontamination of the well, a biocide is required that is effective over the course of a few months in an environment that has a high temperature and salinity. The biocide must also be compatible with the shale in the reservoir itself. As each of the phases have different chemical and environmental profiles, let's take a look at where commonly used biocides are most effective. Oxidizers, like chlorine dioxide, are fast-acting biocides that are very effective at preparing the water topside. Due to their high reactivity, however, they are quickly consumed and not able to provide efficacy after the blender. Surface-active biocides, like TTPC and quats, are also fast-acting biocides and are heat-stable, but due to their formation incompatibility and rapid absorption to reservoir rock, they won't provide efficacy beyond the initial kill topside. DBNPA is the fastest-acting non-oxidizing biocide. It is more selective than chlorine dioxide, making it more chemically available for microbial control. Glutaraldehyde is one of the most versatile and proven biocides on the market and is readily biodegradable. While it's not as fast-acting as DBNPA, it is extremely effective at both preparing the water and decontaminating the well. Similarly, THPS is highly effective in the well, but has compatibility issues with other fluid additives and the formation. DMO and THNM are controlled-release biocides and become effective in the well. They are not negatively impacted by high temperatures, pH levels, or salinity. This makes them very effective at providing long-term protection in the reservoir. As indicated earlier, sometimes the most effective treatment comes from a combination of biocides that takes advantage of the strengths of the two components. Glutaraldehyde is commonly used in combination with quats to leverage their quick-action topside before decontaminating the well. We hope this overview gives you a good idea of which biocide might be the most effective for your operation. If you're not sure of what biocide you are using, check the label of the product you use. The active ingredient will be listed there. If you want to learn more about the strengths and weaknesses of commonly used biocides in oil and gas operations, check out our overview.